Welcome, everyone, to the first webinar in the series of webinars on vegetation classification. My name is Aaron Wells. I'm the secretary of the Vegetation Classification Working Group Steering Committee. This morning, we have the honor of having Professor Javier Loidi join us and present. Javier served as professor of botany at the Complutense University of Madrid for 11 years and at the University of the Basque Country for 35 years. Since 2023, he has been Emeritus Professor at the latter institution. His research interests include vegetation science and geobotany with a focus on vegetation classification, biogeography, and bioclimatology. So, Javier, I'll turn it over to you.
Okay, thank you very much. I want to welcome you by joining this webinar in which I will try to explain one of the issues has been commented in the recent years in our environment, scientific environment, which are the biomes and these big comprehensive units which are used to encompass all the variability of the terrestrial vegetation of the world. Here is a map. It's an old map of the ecozones of the world, in which probably most of you know by heart. You have seen this map or similar to this many times, and most of the units are represented here are suggesting a similar order. How is the world? How is our world today? In this webinar, we are going to give our version of our approach, which is not very distant from this one, and with a general explanation. So, our proposal is to construct a multi-level classification. A multi-level system of classification of the terrestrial vegetation. So multi-level means that we want to have the basic level, the most detailed level. So the plant communities we observe in the land, in our country, in our region, in our town, in our fields, and to make a system which can be constructed up to the highest levels of integration. The idea of doing this is not a new one. I want to take the words of an old, already disappeared colleague who he considered that at that time there were two main approaches for doing classification. One was the physiognomic one, which was a more general and comprehensive, and the floristic system, which was more detailed. And his idea should be made an effort to marry the two approaches into a single system of classification. This idea is given in 1978, so it's quite an old one, but it is very clarivident. So it is it was very much skilled. So the idea is doing something like this, because this approach has been already done, in which we have the upper level, the bottom levels. In the bottom levels, we have the detailed units in red down here, and these join together into higher units, and those into higher units, and so on. But they reach a level in which they intermingle or mix with other units which are conceived from up to down. So the biosphere, the terrestrial, freshwater, marine, and different level of biomes and functional groups and so on. So this idea has been already performed by other authors. So in the case we want to make an approach from the bottom to the most synthetic approach. We have the reality down here. This is a landscape anywhere in the world, and we study the communities in that landscape. And these are, let's say, the associations we can finally describe in our country. There is a number of them, and these associations are joined into alliances The alliances are joined into orders, the orders into classes, by using a floristic approach. This is the typical brown blanket methodology. No? But after the classes, we have really impossible to continue. And the classes are a unit which is too much detailed for describing the big units of the biosphere. So we need something above this. And this is an approach which is down up. So it is inductive, down up. And well, this is the brown blanket approach has been much used in many countries, particularly in continental Europe, but not only. In many other countries has also been applied, and it can be applied anywhere we want to do. We need only to use the floristic composition of the units to make this exercise. If we want to make an opposite exercise, we can conceive big units. This is already our approach. The big units, we consider they are four, and we have considered the four. So the entire world can be divided into four entities. An entity we call cryocratic, because it is governed by cold. Krios is cold in Greek. Thermocratic is governed by heat, so it is the warm units. This is in the middle, mesocratic, and this is another one which is governed by aridity. So finally, we have four units which express the idea that they are dominated by or either cold, either warm, either aridity, or are in the middle. This can be divided by another climatic criterion, which is the seasonality of the precipitations. Post-cryocratic doesn't divide. Xerocratic also doesn't divide. But the mesocratic can be divided into three. Depends of if it rains in summer, if in summer doesn't rain, and summer is arid, or it is very, very continental. And in the warm or tropical areas, we have pluviseasonal, so we have an arid season and a rainy season, or it is raining all the year round. So far we have a system which is governed by climate. It is a climatic criterion, only climate. If we introduce to this climate, we introduce a physiognomy. This can be divided into 9 units. So we can divide the cold areas in the more cold, the coldest ones, the polar, and the boreal. The temperate can be divided into 2, deciduous and evergreen forests. Then the arid for arid areas, summer arid areas, we can divide these temperate arid estival evergreen forests. Steppes are not divided. The deserts are not divided. And these are the tropicals also are not divided. But if we want to make a further division, we can divide the biomes into subbiomes, and then we have 20 units. 20 units in which we can distribute all the ecosystem, all the terrestrial ecosystem of the world. And these are the different subunits we can divide. So the division is from up to down, opposite to the down, the bottom up, which is for the brown blanket system. And then we go to the reality. The reality is where the brown blanket system is really developing. Well, what to do then? We can try to make. Here I represented both approaches. Here is the first approach from the reality, the brown blanket systems here. is represented, and here is represented the other system we have been explaining so far. Then, and what is the connecting unit? The connecting unit is this one. This one. So this one is the connecting units, and they are the regional subbiomes. Of them, we have so far described by 84. 84 units, which are the regional versions of the subbiomes. What are the regional versions of subbiomes? And when these systems overlap. So we divide the subbiomes into regional variants if they are to be divided. So, for instance, there are some variants. For instance, this is the subbiomes of the Arctic tundra, where the Arctic tundra has been divided into two. One will be the Eurasian, and the other will be the North American. And so are going to be divided, all of them. We will see them. And we have finally so far described 84. In any case, the criteria to distinguish all these levels are that in the lower levels, which is the level of the brown blanket system, the brown blanket communities are dependent on dynamism, disturbance, and zonality, azonality, so site conditions. We describe the brown blanket communities by the site conditions and by the dynamic position in the succession. Then the regional subbiome is depending on biogeography, so are the geographical elements also included, and the physiognomy or ecomorphology is the biome and subbiome, and the upper level is climate. So in the opposite way, the general envelope of all the vegetation of the world is climate. So everybody is depending on climate. But if we focus on only physiognomy, how do they look like? Then we have the biome and subbiome levels. If we introduce the biogeography, then we have the regional subbiome. And then if we want to study the communities at a detailed level, we have these 4 levels, which are depending on site conditions and dynamics. But this hierarchy or this degree of criteria are applied with some independence. So, for instance, we have this. This is the example we want to see here. So, this is the lower levels, the lower levels, and we in the lower levels. So, from level 7 to level 4, that means association, alliance, order, class. This is the brown blanket system, and for that we will use the brown blanket names, and we have some examples. We have an example here, 1, 2, 3 examples. These examples try to see, for instance, this is an example of the boreal, in a boreal territory, Vaccinio. This is an example in a Mediterranean country, could be Sicily or whatever. And this is an example of temperate Europe. And then we have that in the zonal, the blue is represented by the zonal communities. The azonal, one of the azonal is the Basque communities, and the brown is these disturbed communities, which are substituting after disturbance to the rest. And then we find that from the associations to alliance to the order and to the class, there is a continuity in the zonal. In the azonal, so these are rocky cliffs. We choose in the azonal type, we can find rocky cliffs. And then we find the one association of rocky cliffs, its alliance, its order, and its class. And if we find disturbed, for instance, this is a wheat community, we find its association, the alliance, the order, and the class. No? And so in this 3 units model, we are represented the the community analysis which is performed by the brown blanket system. If we go to the Mediterranean country, we find the same situation. We have Quercetus rotundifoliae with the alliance Quercionilis, Quercetalia, and if we go to the Quercophagetia, we find it the same. So it is a quite messy, but it is easy to understand. So this is the reality, these are the associations, these are the alliances, these are the orders, and these are the classes. This system is already finished with this approach. We cannot go further with the class because the rest of the units will never be connected by floristic similarities. The rest of the approaches are completely different from in the flora, and then the flora cannot be used to make the classification. The upper level, level 1 and 2 and 3, then we have similar situation. Then we have the upper level are the domains and ecozones. Then we have the biome level with biome and subbiomes, and we have several. We have, for instance, here also examples. And then we have the lower level of in this half, which is the regional one. This is represented one of the regional subbiome. This is in the general subbiome, the biome, the cryocratic, etc. Then, for that approach, it is important to have a bioclimatological classification. So, because climate is going to be used in most of the approaches here at the biome and the domain level. Here are two maps which represent bioclimatic classification. In the upper left, there is the map of Rivas Martinez, World Bioclimates, and in the other map is Elgin box system, which is also being used. So they are not exactly the same, but some similarities can be seen in any case. And climate is the main driver in terrestrial vegetation, but a large spatial scale. In the narrow spatial scale, climate is not so much a determinant factor. But bioclimatic types are needed to define zonal system and ecosystem. So here are the two main authors in the recent literature. Of course, there are other authors in the literature which are older, but these are the most recent one. I am going to present my own approach, which is quite much more simple than those was presented by any one of these two authors. So, bioclimatic classifications. Bioclimate is a variety of climatology. Bioclimatology is a variety of climatology because the bioclimatic types try to match with the distribution patterns of the terrestrial ecosystems. So the types we are going to try to make try to match with the distribution of the biological, with biomes or the vegetation units which are present in the Earth. That is the reason why call it bioclimate. Otherwise should be only climate. And then to create a bioclimatic classification, in one of our papers we have made with Denis Vinokurov, we take climatic data extracted from CHELSA webpage, and a total of 22 variables were calculated, mostly from CHELSA directly and others from other authors. And then finally we selected 616 localities over all the terrestrial lands of the world in a stratified regular distribution that mapped units climatic. And the locals were plotted in a PCA, in which the axis 1 and 2 explain most of the variation. So the 616 locations are represented here in this map. And you see that it is really not a very even distribution, because some areas are very largely represented by, well, the plots are quite separated. And in the others, the plots are quite together. That is because of the topography and the climatic variability we know there are. These are areas in which climate is relatively homogeneous, like here and here, or here. And these are areas in which climatic variability is very high, because there are mountains or there are other conditions that we know that climate changes in a short stretch of land. So, but in any case, we have tried to obtain all the information of the climatic position of the world. And the variables and indexes we have initially chosen are those. This is these are from Chelsea, the BO1, 2, 3, 4, which are here. Well, the normal one, annual mean temperature, isothermality, blah, blah, blah. And here we have added a few of them. So it's like number of frost days, drought of the warmest quarter, which is BO divided by 10, positive temperature, which is a variable which was proposed by Rivas Martinez, which is more or less the sum of all the positive temperatures along the year. So how warm is a climate? Positive precipitation is the sum of the mean precipitation of the months. And this is a quotient, homothermic index by Rivas Martinez, which is the quotient between positive precipitation and temperature. And this is one index of Kira, which is a Japanese author, the coldness, how cold is a location, and has been quite used, particularly in Asia. And we have plotted in the PCA, and we obtained this sort of star, more or less evenly distributed, in which we have chosen a few of the parameters to make our classification, particularly these, temperature annual range, so how is the difference between summer and winter, cold winter, hot summer, or they are quite similar. Then this is bio 15, the same but for precipitations. So this is how the different seasons are rainy, more rainy, less rainy. Then number of frost days to have an idea of how cold is a location, and then to make an idea how warm is a location, TP, and then the quotient between homothermic index, so how arid is one place in relation to the temperature. No? So the precipitation divided by the temperature. Then we have this basic table for the bioclimatic classification. We have made here more or less a hierarchic model. Then we have macro bioclimates and bioclimates. Macro bioclimate, we have separated only four. Warm, arid, mesic, and cold, more or less like the biomes we have initially made. So what is warm? Warm is positive temperature more than 2000. More than 2000. Below 2000, it is not warm. Arid, homothermic is below 1. To be arid is below 1. Mesic is the positive temperature between 1000 and 2000. In cold is positive temperature below 1000. So the numbers are very rough but easy to understand. And then we introduce the bioclimates. And the bioclimates can be, for instance, in the warm, which is more or less tropical, we find the pluvial and the pluviseasonal. Pluvial is that the bio-15 is more or less than 60. Pluvioseasonal bio-16 is the seasonality in precipitation is more than 60. So precipitation, the difference between dry and wet season is low or high. That makes the tropical arid season and the tropical without arid season. In the deserts, so in the arid areas, we have cold deserts and warm temperate desert, because desert can be warm or not so warm. No? We have always the idea that the desert is very hot and warm, but there are not. There are also deserts which are not so warm. And for that, number of frost days more than 50 or less than 40. The MESIC is the most complicated because in the middle of the Earth, there is the strongest climatic variability, and we have separated three. Those areas which are of summer dry, Mediterranean insulato, summer dry, of rainy summer, more or less temperate, called by many people, and then steppe. Steppe is that biome, that is the temperature annual range, so the continentality is very high. All these areas are lower than 300. And then we have the tundral boreal, which is more or less a common one. And then we have, and these are the bioclimates, and that is all. That is all in terms of describing how a general climate is. Then we can separate these categories, which are here in these yellow quadrats, and we make umbrotypes and thermotypes. Umbrotypes, umbrotypes are those in yellow are the only the reality. So yellow and cross, it means that it exists. Out of these empty quadrats really do not exist. Is that the umbrotypes are types of rain. How rainy or how less rainy is one of these bioclimate. So, for instance, we see the warm tropical with warm pluvial, so the warm but all raining all the time. We have only humid and hyperhumid. So this means that IO is between 6 and 12 and more than 12. It doesn't exist tropical pluvial or warm pluvial arid or hyperarid or subarid. It doesn't exist. So that is why it is in white here. Opposite, in the arid, it only exists the arid versions. This is not existing. And so are the rest. Why do we make this? Because in the description of a climatic type, we can use these umbrotypes to say if one arid estival Mediterranean is subarid, dry, subhumid, humid, or hyperhumid. So these varieties give an additional information on how rainy is this bioclimatic type. And then we make the same, but with thermotypes. This is how warm or how cold is. Okay? So in the pluvial, then we have these varieties, and well, in the how cold are all those possibilities. No. So, and this is really an idea. It was expanded by the French geographers and climatologists who existed in the mid of the 20th century, particularly Daguerre, de Gossin, Bagnols, etc. And they found that the climatic types could be described after the zonation was found in the different, the zonation was found in the mountains in North Africa. In North Africa, you have the Atlas Mountains, and then you say, well, we have a Mediterranean climate, and this Mediterranean climate can present several varieties. If we are in the bottom, If we're in the lowlands, we have a warm climate, and if we are in the top of the mountain, we have a cold climate. But the climatic envelopes being the same. We are in the Mediterranean, which is summer dry, and then there are thermic variants, only thermic variants, to say that for the description of this climate, no? And that is the idea. For instance, for description in one locality, we can say that we are in a pluviseasonal, subhumid, and supra location. And with these three words, we are making a description of the climate of that locality by following a more or less bioclimatic criterion. Or we make this one, these were mesic, the arid estival, so Mediterranean, subarid and thermo, and so on. One of the main concerns for many years of the geobotanist, which has really not been solved satisfactorily, is the relationship between altitude and latitude. This is a very, very old question. And here is one of the oldest drawings by Alexander von Humboldt. He liked it very much to compare the mountains of the different parts of the world. Here we have the Andes, here we have the mountain of Tenerife, and here we have the Himalayas. So to compare this different mountain was one of the most difficult points. And there is always the idea that the altitude represents latitude somehow. No? There is a representation of latitude and altitude. And that is more or less true. In our system, we have defined the thermotypes, as we have seen in the table before. And the representation of the thermotypes, what is the span of the thermotypes in the world from the equator to the pole? No? And we say that the hottest or the warmest thermotype, the infra, it spans up to the 30 degree, and the thermo to the 40, the meso to the 50, and so on. And the Griora, which is the coldest, reaches 80 degrees, but there is nothing between 80 and 90 because it's only ice, really, the poles. And these can be expanded in altitude also. So in a manner that if we go to altitude, for instance, in the degree 5, which is in the tropics, then we will find infra conditions up to the 1,000 meters, and then we find meso conditions and so on up to the almost 5,000 or 490, 5,000 meters, in which vegetation already disappears even in here. So, and in the mountains, in the case of the mountains, we have mountains all along these gradients or this scenery. So and this is more or less the McKinley Peak, and these are other mountains in different positions, highlands, and each mountain has a different size on altitude and so on, but they will cross these regions so that, for instance, in this mountain, which is expected to be the Andes, for instance, which reaches 6,000 meters, well, in the Andes mountains, from the lowlands, from the base up to there, you will find all these thermotypes. But in a mountain, you are in, for instance, in the Alps or so, you will find only 3 types of thermotypes. So the zonation will be much more simple, or the Scandinavian Alps. Here you have in the Scandinavian Alps only 2 thermotypes, and in the McKinley only 1, of course. So this is a way of trying to compare what is the relationship between altitude and latitude. If we went to make a survey on the Earth by using all the points in which the Chelsea gives us the information, then we can find the how warm is the world and how cold. Of course, positive temperature, and we see which are the warmest places of the world. You see so the places where the thermicity is the higher are here in the Sahara, and some are in the Arabia and in India and so on. Not so much in America, interestingly. And the coldest areas are, of course, in the northern hemisphere and higher latitudes. So Greenland, northern Canada, Alaska, northern Eurasia, in comparison to the southern hemisphere, which are much, much less cold. The mountains, of course, bring always cold here in the Andes, and particularly the Himalaya, which is a big cold base. And we can make the line of TP1000 to separate the cold climatic environments with those which are not so cold. And we separate here the Arctic and the boreal variants here. If we want to see how arid is the world, aridity in terms of IO, indices of homothermic index or aridity, so positive precipitation divided by temperature, we find the most arid area are here, of course, in North Africa, in Sahara, and also in this Taklamakan desert in Central Asia, and also in the coastal desert of South America between Chile and Peru. This is the most arid areas, probably in the coast of Namibia and South Africa also. But the rest are so. But in any case, if we want to see the line of ION1, so the arid territories can be drawn quite exactly in coincidence with this climatic type. And if we want to see continentality, that is another point. Continentality is interesting because the most continental areas, in the red color, are here in the northern hemisphere, particularly here in the Baffin Island and in eastern Siberia. These are the most continental territories of the world by far. And then in the southern hemisphere is practically not continental. Southern hemisphere is much water, and continentality is very low. It's very low in comparison to. So in the upper levels, physiognomy and climate, and then we can make a short discussion about the biomes. Biomes has been described in many ways, and it is really a polysemic or controversial concept because practically every author has a different idea what really a biome is. Some biome is something very big, but nobody knows what are exactly the limits of biome. In our opinion, in a paper we published in the year 21 and some other authors also, the biome is an entity which has an inclusive character. It includes all the biotas, all the communities, the ecological processes, and also the diversity of the topographic situations. So the regular ecological gradients. And it is a global concept which can be connected with the zonal vegetation type. So it has a physiognomical basis and a climatic one, but physiognomical also. And is the morphological traits of the dominant vegetation. The dominant vegetation, we call it the zonal vegetation, and has been called formation in many authors. It is determined also by climatic conditions. So biomes are the biotic contents of the climatic types. And here we introduce the terms of zonality, and they cover all the terrestrial areas of the world. So zonality, it is a very important concept because relates the vegetation types and the climate. So we have to find in any part of the world what is the vegetation type which is in harmony with the climate and is not disturbed by other factors such as disturbance or site conditions. And the zonality provides also the referential models of ideal natural lakes, which can be used for ecological restoration and so on. In this scheme, I try to explain what is the zonal and what is the azonality. The zonal is this part, I put it here, and this is a model of how a profile of the terrain is. No? So this is a hill, and the bottom hill, valley bottom, and this is the slope. And well, this can be found anywhere in the world. We can find a profile like this everywhere in the world. And we have to know that this upper part, the crest, is always drier. And this lower part is always moister. So everybody knows that. And in the middle is the intermediate situation. We consider that both crest and Piedmont and Valley Bottom are not zonal because they either lose water by gravity, more water than it rains is lost by gravity, and they receive for gravity more water than it rains. So in the middle, it's considered they have the real relationship, the univocal relationship with the climate. And that's the reason why we put here climatophile. And here we have to say edaphoxerophile, that means that the soil is dry, and here edaphohygrophile, that is this more hydric, so more moisture than receives from the rain. And then we focus in the zonal, because the zonal is giving us information about the real climate. This is another example. This is a drawing of one valley in the Alps. The Alps, very high mountains. And, well, we have this picture. And in this picture, we see that there are many, many situations. A lot of situations. We have a crest, we have a scree, we have another scree, we have cliffs, we have a river. So, and slopes, no, more or less regular slopes. And then we make a survey of the vegetation. We can know, and we put numbers on the vegetation types we have after our survey, and we put the same number. For instance, number 2 corresponds to this and to this, because they will have probably cliff vegetation. This is number 1 because it will have a scree, and this is also number 1 because it will probably other cliff, and so on. So these numbers mean that you have different vegetation communities in your reality. In your reality. So finally, you have 37 types here. Well, 37 is the last number. And then we say, what is the zonality? The zonality is separated here by the red line. What is inside of the red line are separated, of course, the number 14, and some other here is also 14. The number 14, and it is the area in which it is not the driest position, the driest position are here, nor the wettest position. The wettest position are here. So we exclude this. And then we make a sort of intermediate vegetation, which is a representation, which represents the climate of this valley. Probably this valley spans 300-400 meters of elevation, so it is not so different in climate between the upper levels and the lower ones, maybe not, but in any case, we want to know what is the zonal vegetation. And the zonal vegetation is in slopes, always is in slopes of intermediate tilt. So then we have the biomes classification, and we have also the domains, the ecozones, biomes, and subbiomes. And here we have the domains. We have seen it before, the cryocratic domains. We have the coldest one in the middle, the driest, and the warmest. And here we see a map of the world in which we are represented the 4 units here. The cryocratic, the coldest one, the coldest areas, the mountains, or the Alps. Other mountains are not represented because it's very small. Then we have the middle ones, in the middle, in green, and these are the xerocratic, which is the arid areas of the world, which are distributed in this, and the warm, not arid areas of the world, in tropical countries, particularly in Asia, Northern Australia, Africa, and America. Ecozones, we have separated from them, depending on the type of the climate, and we have separated, for instance, well, for the cryocratic, there is no separation, it's all cold. And for the deserts, also no separation. But for the mesic, we have separated into 3. We have summer rain. We have summer rain in green. We have summer dry in brown. This is the summer dry areas in the temperate. And here we have the steppe ones. The steppe ones. Note that the steppe ones, the steppe units, are only in the northern hemisphere. Only in the northern. There is no steppes in the southern hemisphere in this sense. Why? Because the southern hemisphere is not so continental. Steppe in the bioclimatic sense also. Then we have the biomes, which are 9, the tundra, the boreal forest, and we have divided here the different mesic types. So we have 2 pluvial evergreen, temperate arid estival, the steppes, and then we have the deserts and the 2 types of the tropical. So we are dividing more or less like before, but with more units. And we have the different Mediterranean and so on. And these are 9 units. So it is interesting that the tropical unit is divided into 2, the tropical pluviseasonal and the tropical pluvial. The tropical pluvial is raining all the year round, and the pluviseasonal is raining only the rainy season. And the subbiomes, which are here, the 20 units. And here is the system in which each of the biomes can be found in the different continents. So we are not paying attention to the species or even to the taxa. The taxa are not important here. It's only climate and physiognomy. And then we can make this unit, for instance, the tropical rainforest in Africa, the same as in South America, the same as in Southeastern Asia. So they are the same from the subbiomes or the biomes approach. The same for Africa here and for this Brazilian area, or the same for the boreal forest, North American, and for the Eurasian boreal forest. Pay attention that this cold boreal forest is also absent in the southern hemisphere. Southern hemisphere, well, we have only a very little representation here, very small. Then no attention to the taxa. But if we want to make, and these are units which can be defined by climatic types. These are the domains and biomes, and these are the climatic types. So the different macrobioclimates and the climates. And here are the biomes, the subbiomes, how are defined in this system. And then here is the representation of all the subbiomes by continents. We see Africa, in which we have a very important representation of tropical biomes, subbiomes, and of desertic ones. In the north, we have Mediterranean. This is Mediterranean. And in the south, we have also Mediterranean, in the cave region and deserts. Asia, of course, is the biggest continent. We have many important things. Here we have the boreal area, the Arctic tundra, the mountain tundra in the Himalayas, very important, very important. And here are the arid regions of Central Asia, the deserts, the Gobi and the Taklamakan. And here are the boreal forests of the Oro levels, or the subalpines, here in some of the mountains. Well, and in the south, we have the tropical units. Here, it is interesting to see how the Himalayas introduce this mountain subtropical level to here in the southern slope of the Himalayas up to the Kashmir. This is a very interesting, the rhododendron forest. Australasia is also, well, it's the smallest continent, the smallest populated continent. And here we have the tropical units with the mountains of New Guinea, particularly. On the Australian continent, we have a northern, which is tropical, and the southern part, which is xeric, and the Mediterranean, and this is the temperate, together with the New Zealand. Europe, which is the continent where I live, well, more or less we know all this. We have the boreal forest, we have the tundra here up to the North Cape. We have the mountain tundra here in the Alps and in the Iceland. And we have south to the boreal forest, we have the temperate summer green forest from western Spain, northern Portugal up to Russia, and to the Balkans, and to even southern Italy, even to Sicily. We have all this very much expanded. And then we have the Mediterranean ecosystems here, which expand in the west, particularly in the Iberian Peninsula and North Africa, but are also represented in the islands and in Italy and so on. And in America, we have this big difference between the east and the west of America. This is mountainous, and this is more complicated climatic types, and this is more similar to here. And South America, no? Where it's mostly tropical, except the southern extreme, in which find other biomes, also biomes, which are representing, this is the typical Patagonian unit. And these are the temperate or the pluvial, or sorry, the oceanic system. This is the well. This approach is interesting because it is an exercise we made by projecting the biomes. These are the 9 biomes of the world represented. It is virtual distribution in latitude and altitude. This is the altitude, and this is the latitude. This is latitude 0. This is southern hemisphere. This is 0 northern hemisphere. And this tries to represent the Americas. This is the vision number A, profile number A. That is if we can see America from the Pacific in a big eye, no? America from the Pacific. So we find here, this would be Alaska, this will be Canada, United States, and Central America, Southern America, up to Patagonia. And with the different mountains. Of course, the scale of the mountains is much expanded. No? And we represent some of the most important mountains that really exist there. So from Mount Denali, Mount Whitney, Mexican Sierra Madre, Chiripo in Costa Rica, Chimborazo in Ecuador, Huascarán in Peru, the Andes, Aconcagua in Chile, and the Southern Andes. And these are the mountains in which, and this is the virtual distribution of the biomes. The gray is the Arctic biome, so the tundra. See, the gray one, number 1 is the tundra, and the tundra is in the sea level in these latitudes. So here in Alaska or in northern Canada, we find the tundra at the sea level. And then if we go more to the Ecuador, we will find tundra, but at higher elevations. And only few of the mountains will reach the tundra level. For instance, the big Andes, or in the Aconcagua, you will find the tundra level. And then we find other biome types. For instance, the boreal forest. Boreal forest is mostly in the northern hemisphere, a little bit here in the southern hemisphere, very little. But you will find it here from the sea level to a certain elevation. And then some other biomes are only found at the sea level. They never have a projection in altitude, because the altitude means that the arid types vanish. It is very important that. So these types, for instance, are vanished and are replaced by this cold system. In here, near the equator, they are temperate pluvioseasonal forests. And here are the tropical ones, which are also in the lowlands to a certain altitude, particularly between 1,500 or 2,000 at the most. And here we find the other situation. So here is represented that depending on what altitude has your mountain, it will have these different biomes in the Piedmont or in the mid levels or in the top. For instance, the Huascarán in Peru, in central Andes, the top has no vegetation, nothing, nor tundra, it's too high. They have a part of tropical tundra, and then they have a part of forest, and then they have other in the lowlands. No? This is the profile of D. D is if you see Asia and Australasia from the Pacific too. And then you have Kamchatka, this is in Siberia, this is Japan, this is Yushan, this is Taipei, I mean, the island of Formosa, how is it? Taiwan. This is Taiwan, and these are this is New Guinea, mountain of New Guinea, and this is Australia, and this is New Zealand. No? And then you have the same exercise, how are distributed the biomes. Then we have another two more. We have seen this one. This is Europe from Africa, and Africa from the Atlantic. And so this is the same exercise. You can have a look if you want to see how are they represented. So this is an attempt also to connect the altitude of the mountains with the latitude. So in latitude, we have this zonation of biomes from 70 to 80 degrees, north and south. But in altitude, we have this zonation, which is not exactly the same, because, for instance, in the tropical lowlands, this is tropical rainforest, at certain altitude vanishes, cannot be anywhere in the altitude, no? And so on. And then it is coming biogeography. Biogeography, I don't know if I am too late, but if you can say me something if it is too much time. I mean, biogeography, it is the combination which make the connecting units in these two. It's a discipline which is devoted to the distribution of taxa across geographical space and through geological time. So it has to do with distribution, with dispersal, and with evolution. So it is not really an purely ecological approach. It has to do also with history and what happened in the past concerning evolution, and what were the ways the different species migrated in the space. So the biogeographic or phytogeographic territory really encompass all these ideas. So you have the plant, you have the flora, the vegetation, the flora, the plant communities all together under human influence. And this is, of course, the non-biotic factors and the the substrate factors interact. Probably you know, well, there are several approaches about the kingdoms of the world. This is a very old approach. We made the typical 6 kingdoms of the world, and we have, say, the Polarctic, Neotropical, Paleotropical, Australian, Capensis, and Holo-Antarctic or Antarctic. No? So, Holarctic, Antarctic, Holarctic, Holo-Antarctic. Tropical is divided into 2. Australia is separated because it is a very ancient and isolated land which has evolved separately, and the Capensis because it has very, very extraordinary singularities. And traditionally, the kingdoms have been divided into regions, which is the next level. And the regions are described here, and we have 42 regions, which have to do with the families and so on. There is a general description of the regions. So some of the regions are between 2 continents. One is bicontinental, so it has participated into 2 continents. Number 2 also participates into 2 continents. They are too close, but already there is no more. The rest of the regions are in a separate continent. So we have 3. This is the Euro-Siberian, this is the Eastern American, this is the Irano-Turanian, the Eastern Asian, so on. No? And they have all the names here. These are the region, which is quite a traditional approach, very close to that was made by Tartayan in the 80s and Good in the 60s. So then we have these levels, and we have the regional subbiome. So we have made the regional subbiome. So subbiome have been divided into regions because one subbiome can be into different continents, and in each continent we make a different subbiome. So this is, for instance, all the 42. These are the 42 regions we have separate, and these are the subbiomes, up to here, no? And then we see how much of each subbiome is in this region. For instance, the tundra, polar tundra, this 1A is 100% in the circumarctic. All the polar tundra we have in the world is in the circumarctic. Well, what about the 2A? 2A is lowland boreal taiga. The boreal taiga is mostly in the circumboreal region, practically all. Well, the rest of the are very little or nothing practically. Then, and so we can make a different and so on. So, for instance, if we find polar tundra is 100% in one region, and we have a little bit in some other places, like here, for instance, the subantarctic archipelagos, Kerguelen and all these islands, southern Orchards and so on, they are 100% also covered by Arctic tundra. So we have to subdivide the polar tundra into 2 or 3 regional subbiomes. If we want to temperate deciduous forest, the temperate deciduous forest is the deciduous forest we have in Europe or in Eastern North America. We have it here that the Euro-Siberian, the Chinese, Japanese, and the North American are here, and also a little bit in the Valdivian Magellanic, that is in the southern Andes. So we have 4 territories of the world in which we have this subbiome. So we will have to make 4 regional subbiomes with it. But if we choose tropical rainforest, number 12, in tropical rainforest, we have in all these regions of the world 12 regions of the world. So this subbiome is represented in 12 regions of the world. What does it mean? That in each of these regions, there will be a different flora. They have the same sub-biome, but they have different flora. As it happens, for instance, with temperate deciduous forest. Many of you probably come from this territory. And then we have a temperate deciduous forest in Europe. We know, or the plants are there, Fagus sylvatica and that. Then in North America, we have similar forests, but with different species, because we are in America, and biogeography is different. And in East Asia, there are also different species, and in the Southern Andes, also different. Here we have the same phenomenon, but for 12 occasions, so it multiplies. And that is the point. And these are the regional subbiomes we have found for Africa, for instance. These are with the different colors. We have the tundras of the upper mountains, but then we have the evergreen forest, the evergreen forest in the different regions of Africa, Ethiopian, Sub-Arabian, with the numbers. We have the deserts. We have the regional biomes in the desert, the Karoo Namibian, Sahara Indian, Ethiopian, blah, blah, blah. And then we have the tropical ones, no? With number 8 and so on. And we have also the number 10. But for Asia, we have the same, the regional subbiome. Each region has its own regional one, and for the rest of the continents too. Well, I'm not going to explain each of them because we have no time and so on. So, azonality includes azonal edaphoceraphyll and edaphoceraphyll egraph. Then, with disturbance, the disturbance is also a very important element in the analysis of plant communities. And the disturbance, we have to separate between the natural and the anthropogenic disturbance regimes. The natural is, here is the list, more or less, from the less severe to the most severe. So we have landslide, extreme droughts, etc. And anthropogenic, we have, of course, these disturbances which are due to humans. And this is the hypothetical reconstruction of the potential natural vegetation after disturbance, how much time takes to recover from one. Well, and that is basically what I wanted to tell you. Thank you very much.
Well, thank you, Javier. That was very interesting. We'll take a few questions now. I know we're over time, but if people are interested, please put your questions in the chat, and I'll read them out to you, Javier, and we can go from there.
Where should I see the
Up at the top, you'll see the chat icon.
The chat.
But yeah, if we have any questions, yeah, put them out there.
Vamos a ver. Well, in any case, all this has been published and is available in literature. So, and I am also available for any questions you want to make by email after, whatever you want.
Okay, well, not seeing any questions. Yeah, let's put our hands together virtually and thank Javier for presenting today. Thank you so much.
Thank you so much to you and to all the participants.
Right. Have a great day, everyone. Goodbye.
Thank you.
Or evening. Goodbye.